Hi everyone, in this video we're going to talk about the power of a power rule for exponents. So the objective of this is I can apply the power of a power rule for exponents to write equivalent or equal numerical expressions. So we're going to look at what happens when we have an exponent and then there's another exponent on top of that. So let's look at an example first. So this is what an example looks like. So to say this out loud, we say 5 to the power of 6 to the power of 2. So 5 to the 6th squared is another way you could say it. So again, an exponent means that's how many times you multiply something. So this 5 to the 6th is kind of like our base now. So our base is 5 to the 6th with an exponent of 2. So that means I multiply 5 to the 6th twice. That's what an exponent tells us. An exponent tells us how many times to multiply the base. So multiplying 5 to the 6th twice looks like 5 to the 6th times 5 to the 6th. Using the product rule is when we multiply numbers that have exponents. The product rule tells us if the base is the same, we keep the base and add the exponents. So 5 to the 6 plus 6 is 12, 5 to the 12th. How could we have solved that just by looking at the original problem? Well, if I go back to the original, I have 5 to the 6th squared, or to the second. And what's the relationship between 6 and 2 and the final answer of 12? Well, 6 times 2 is 12. So I could have just multiplied the exponents. And that's what the power rule says. The power rule tells us that to raise a power to a power, just multiply the exponents. So a to the m to the n, a to the m to the n, equals a to the m times n. So you multiply the exponents. Let's do some examples. So the first set over here, we're just going to rewrite each expression. So my base, or this number or expression, is y to the third squared. Y to the power of 3 to the power of 2. So that's the same thing as saying y cubed, or y to the third times y to the third. And then using the product rule, we can add the exponents. So the product rule says we just add them. 3 plus 3 is 6. But I can also just multiply 3 and 2. So the next one, let's just multiply them out. So I keep my base, which is x, and then multiply the exponents. 5 times 3 is 15. So this is x to the 15th. And then we can also simplify, doing our regular simplification in standard form, which is writing it all out, or writing like the final answer. So 3 squared to the 4th. So the power rule says that I can just multiply the exponents. So keep the base of 3, multiply the exponents. 2 times 4 is 8. And then I would need to get a calculator out to do 3 to the 8th. So that's what I'm going to do right now. Take my calculator out because I'm not going to do that in my head. So 3 to the power of 8 equals 6,561. All right, and last one, 2 squared, or 5. So 5 times 2 squared squared. So I'm going to do my power rule first, right here, which says I can take the exponents and multiply them. So 2 squared would be 2 to the 4th, because 2 times 2 is 4. And then what is 2 to the 4th? Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it would be 5 times 16, which equals 5 times 16 is 80. So the answer is 80. Another way to think about this is just using order of operations. So so I keep the 5, use the parentheses first. So 2 squared is 4, and then squared. So then I could have done 4 squared is 16, and then kept the 5 and did 5 times 16. So kind of 2 ways to do it. That's all. Thank you.